Thank you, everyone. Hello. Hello online. Hello, room. It's about half and half, actually. I mean, that's stretching it a little bit, but far off. Thank you, Tony. I'm going to build on something you said, actually, in a minute. So I'm John McAleely, and I'm here to talk about customizing programming languages. I've been curious for the last, 6 months or so about why all microcontroller languages, and I will stand by that all, are cut-down versions of something. Why aren't they specialized for the purpose? I'm curious about that. Feel free to pick me up on the all in the questions. And I've started writing a new one. That's something I'm working on. And I'll talk about that later. This is about how you might want to do it yourself. So if you share my curiosity, why are languages cut down? Why aren't they specialized for the purpose? This presentation is going to be about how to write your own. And I've used this material to do exactly that. A little bit about me. I've been practicing software engineering. For those of you who don't know, that's where I see the big screen in the room. I've been practicing software engineering since the mid-90s on various things, including around hardware and also further up the stack in some things. What you see on the screen in front of you, transmissionbegins.com, that's my personal website, so feel free to check that out. The QR code I'll show again at the end. It's a link to the presentation. So if you want to grab the presentation, follow up later, scan the QR code, and it will appear again on the last slide. And then the code, everything I'm going to talk about is on GitHub. There's a link there. There's a PDF on the other side of the QR code, which you can get all the links from. It's all MIT license. Do it like that. So with that, what do I want to talk about? I want to talk about customizing looks. I'll come back to defining looks in a second. It's a language that gets me started. If you want to write your own programming language, what have you got to do? You've got to bring up the code you've got on the Pico. So that's porting locks. And then I discovered I needed to add 3 features to it to make it viable for sort of minimal work on a microcontroller. All the data sheets have hex in them. You need to be able to write hex constants, otherwise you'll go slowly mad trying to translate everything into decimal. All of those data sheets assume you're going to manipulate those constants with bitwise operations. They expect you to shift them left or shift them right or AND or them together. So you need some of those in the language. And then I really love this part. You need to be able to write to memory addressable registers. And just assigning a variable doesn't quite work because you need to be sure the write is made, and the C compiler will occasionally optimize them away because it's quite clever. So I resurrected peek and poke from my days back in the day when that was what BASIC had. It turns out it's quite popular. There's lots of languages with peek and poke. Although Wikipedia claims these are archaic, so I'm also on a mission to bring them back to modernity. So with those 3 changes to the language, then I want to do Hello World for a microcontroller, and of course that's turning on the LED. So I will demo that later. I'll demo the port, and then I'll demo turning on an LED. What you see in the picture is a little more advanced. So I did say what I'm talking about here is how to do this yourself. Check out the code. You can start your own. I've done that. I've gone a bit further. On my own project, I can run Conway's Life. So the picture you see is Conway's Life. And if I can just highlight it, if I go to this, and do this. So you see an LED cube running Conway's Life. It's handily labeled. And then this is my own board running a standard Pico. So this is the Pico 1, not the Pico 2 that Tony was using. And it's the board that just jumpers across to that 40-pin Raspberry Pi connector. So the LED cube was originally sold to me for the Raspberry Pi, and I wanted to run it from the Pico. So I drew up a board in KiCad. Okay, so let's get rid of my annotations. That. And move on. So, what is LOX? So LOX is the name of a language that's in a book, Crafting Interpreters, that appears to have been around for a while, but was published in 2021. The GitHub repo goes back a couple of years before that. And the author of the book, he now works on Dart at Google, sets out with the objective of teaching you how to write a language interpreter and giving you the kit to then write your own. The book actually does 2 implementations, one in Java and one in C. And it's a modern interpreted language in the sense that it doesn't just interpret your code. It scans it, it parses it, it compiles it, then it runs it on a bytecode VM. It's got modern language features, garbage collection closures, types. And all of this, these are all keywords. If you look at MicroPython, you'll find all of these as keywords in its implementation. They're more advanced versions, of course, because MicroPython's been around a while. This touches on your point, Tony. It's quite fast. A modern Pico has a lot of resources available. And sure, you are spending some of them on all of this stuff, but you get some stuff in return, right? So this really interested me as I read the book. I thought, hang on a second, this sounds interesting. And I think all of this will run on a Pico. So that was my first job, was to get it running on a Pico. It comes with native function extensions, which I'll talk about in a minute. That's a key way into the puzzle. So yeah, follow the link. The book is free, or you can buy it. I suppose it's MIT as well, MIT licensed. So first job, I said there were two jobs: porting to the Pico and then adding 3 features. Porting to the Pico is, I cheated, right? I downloaded the VS Code because, why not? And then I downloaded inside VS Code the Raspberry Pi Pico extension, and I asked it to produce the Hello World sample. Asked it to compile it, and then copied it across the Pico, and it worked. I was like, well, this is easy. How hard can this get? This is fun. And then I literally took the C source code from the CLOX project and moved them into that project and hit compile. And it worked. Well, it didn't quite. The last bullet reveals the one thing that went wrong. So it crashed first time because it turns out the default stack size, so it allocates a stack for execution, was about 1 megabyte, I think, and that is more RAM than there is on the Pico. So you need to reduce that number. But that's it. That was the one number I changed, and then it worked from that point onwards. While later I realized I'd missed something else. So I mentioned there's a garbage collector in it. It turns out that wasn't working because that was waiting till 1 megabyte of memory had been allocated. So I had to reduce that as well. Then I got it working. But yeah, so taking this tutorial, he's careful to define it, wants to talk about it as production worthy. It's not tutorial code. It's not example code. It is something you can take to production. Taking that, getting it working on the Pico was the work of Googling, downloading, and trying it out. And it worked. I was very pleased with the result. So now I will proceed to demo that. And that is going to prove to be a game while I fuss with cameras and things. If I do this, it's going to do it. Switch camera. Found it. There you go. Meeting, switch camera. Here we go. There we go. So that is a standard. If I can orient myself on where that is on my screen. There we go. That is a standard Pico. Just the Pico 1. So this one doesn't have any of the fun things that Tony was talking about. Only has less than 32 IOs. I forget the exact number. And doesn't have the pull-up resistor problem either. In the original Pico 1, they didn't have that problem. It was Pico 2 that got that wrong. And the point here is this is all working on the oldest stuff as well. I'm not using the highest performance Pico. And then if I pull up VS Code, no, first thing I need to do in grand tradition is drag across a UF2 file onto my Pico, wait for it to flash. Is it going to do it? Do I get demo gods? Spinner. Interestingly, the spinner I see is the one thing you're not seeing. So I have to I'm going to try that again. So that's there. Yes, I did. And then I crack on again. Right. So those of you who don't know, just hold down the boot cell button on the Pico, insert it. This is connected to my Mac. It's just USB. And hopefully, if it's not been asleep for a while, it will just work this time. That's right. So it's rebooted. Switch to Visual VS Code and connect to, come on. Why is that not working? I'm definitely having demo problems. Let's do where. Let's start again. Serial monitor. I think it's work this time. So yeah, set it all up before the talk, thinking I was getting prepared, and I did the wrong thing. Right, I should have just done this live. So bring up the USB modem. and start monitoring. That is now talking to the Pico. So in the bottom half of the screen there, and if I press enter, you get the little chevron greater than, less than, I can never remember that, which is LOX offering you to type some code, just like on Python. So let's do that. Print. Hello. Right. It's a C-based like style language. So once semicolons at the end, it's different from MicroPython. Press that, and it comes back with "Hello, Raspberry Pi." There we go. So that was very satisfying when that happened. I had got a language working on the Pico with essentially no original work. I can claim nothing other than thinking that might work, and it does. So if you fancy having a go, have a go. So where did I go next? So how did I change camera? Zoom. Meeting, switch camera, and then get the presentation going. Right, as you can see, I did prepare in case the demo went wrong. You can see the demo is in the picture. So if you get the slides, you'll get a remember. So next thing to do then is to think about what I actually want. So I've got a language working on the Pi, but I want a language that actually works for microcontroller development. What do I want? I want what's on screen here. I want to be able to set a couple of variables. 25 is the GPIO that the built-in green LED is on. I'm going to use a Boolean, true or false, in or out. I will want out. I will want the LED to turn on. And then I just need to get it to do its thing. I'm going to call 3 functions: GPIO init to set up the GPIO blocks. Set direction, I want output and input. And then the last function there, GPIO put, is to put a true, a Boolean, 1, on the GPIO, and the light will turn on. Hello world. Sounds easy. This is pure LOX. I've made no changes yet. You can write this code in LOX. It's just the language that comes out of the box. And you can implement each of these functions in C via that native extension that I mentioned. And I did that. You cut and paste the code from the SDK. Therefore, these functions exist in the SDK. It works. I thought, oh, that's pretty cool. That's not the demo I want to do there. What I want to do is implement this in LOX. I want to be able to do something like this. And here I'm implementing the function GPIO put. That's the simplest one for the slides. The others are all the same, but a bit different. They're different on the Pico 2 as well. This demo only works on the Pico 1 because the GPIOs on the Pico 2 are different, as I discovered partway through this. I want to be able to get some constants from the data sheet. Let's get my I want to be able to take some constants from the data sheet. These are all names you'll find on the data sheet, and they're all in hex. So highlighted in red is the changes I'm making. So it's the hex constants. And then I'm going to write the value to memory somewhere. That's the register that controls GPIOs, to send a 1 to it. And that's this here. And that's 1 in the 25th, or maybe 26th, back to the 0 counting thing, position in the register for GPIO 25. So you do that every data sheet. Will show you doing it with a shift. So why not? And then finally, you need to write that to memory in a way that the compiler will not optimize away. That's a key step. Average writes might just get optimized away. So that's why you need something to tell the compiler to do something different. Inside C, you use the keyword volatile. That's what that keyword is often used for. It can be used for other things as well. In LOX, I'm going to create a statement. It's archaic according to Wikipedia. I'm going to have what I like. So I need to make 3 changes to the language, and then I can run this code. And I will run this code in the later demo. So the first change is hex constants. This is a pure convenience for me as a person programming. The computer doesn't care. They all become binary numbers eventually, and the computer really doesn't care. LOX actually uses floating point numbers by default. I'll come back to what that means in a second. So we need a way of writing those in hex, just like C. You can get into a bit of, I've been reading a lot about programming languages as part of this, and there's lots of other ways of doing this notation if you want. I'm not a C hacker, so I went with the C one. You create a new token, you multiply each digit by base 16, and you've got the digit, not pretty simple. This change doesn't impact the rest of the code. It's literally visible only in the source code, really. So it's quite a simple change. What you see is the link to the actual full change. If you're curious, about the code. No, I'm not showing me, I'm showing my demo. Never mind. So first one was hex operations. Second one is bitwise operations. What we need to do here is a bit more complicated. We want to be able to say that there's some bits in memory that were a number or are a number and shuffle them around either left or right, or maybe and or them. That is only meaningful on something that looks like an integer machine word. So on the Pico, that's a 32-bit unsigned integer. Other things are possible. Very specifically, it's not floating point number, because actually that's 3 numbers. And if you start shuffling bits around, you'll just get confusion. So LOX uses floating point numbers for friendliness. Turns out not to be problematic performance-wise. So what I'm going to do is cheat a little bit. I'm going to extract a 32-bit number whenever I want one, do the operation on it, and then put it back. I could add 32-bit support to the entire language if I wanted to. That's a lot of code, and I'd be here all night talking about how to do that. So I wanted to make progress. So I just take the parameter out, do the operation, put it back. And then because I'm a nice friendly language, I error if that fails for some reason. So if the number was too big, or if I've discovered a floating point number, these things. That doesn't happen in practice, and the performance is fine. It will happen if you start dividing. You'll start seeing weird errors, like you start creating floating point numbers and then trying to shift them. Just very rarely do you do divide other than shifting on constants in a data sheet. So there's a bit of a hack, but it gets progress, and later I'll fix it by doing full support for signed integers. Then the last change is the exciting one from the point of view of the name, which is to put peek and poke in. And these, if you're of a certain age, or if you've looked at some early basics, it's in other languages as well. Wikipedia will give you a long list. Peek and poke. So peek reads from memory, and again guarantees to read and do nothing else. One of the reasons I've gone with function names is registers are potentially sensitive to how often you read them, how often you write to them, whether they support both of those operations, what they mean. So I wanted the language to be able to be quite explicit. If you say peek, you will read once from one address. If you say poke, you will write once to one address, guaranteed in the language. Peek is dead easy. It's just using that native function extension, like I used earlier. It just reads a number. It's volatile on the C implementation. Poke is more interesting. I won't put the code here. It's up linked. Feel free to have a browse and ask me questions later date. But actually, secretly, it's just following a chapter in the book. The book walks you through building a language bit by bit. So if you go back and read the bit about how to add print, you're just doing a 2-parameter version of that. It's the same statement. So I did exactly that. And with that, I can do another demo. So I see the camera is still live. So let's see if I get VS Code live again. So let's see what now. If you look at the top half of the screen, I was misdirecting you away from that earlier, you will see the code that I was just showing. So that is a set of constants and GPI output. So just for the niceness of a demo, I will cut and paste that and run that. Doesn't do anything yet. You see it echoed back as part of the process. I now need to feed in a lot more code. Remember I said there was 3 other functions. So I've got a class for manipulating registers. The language has classes already. I have to add those. More constants we need. I'm only doing this bit by bit because there's a small buffer on the serial thing. Could set the whole thing if it had a buffer. These are these other 2 functions. And as you can see, if you're reading closely, or if you go look at the code in thing, they are implemented in terms of peek, poke, bitwise operations, and hex constants. There's no difference between them. And then finally, we need GPI, which is just calling functions we've already got. And then if I scroll down further, you will recognize the code from the first slide. So this is what I wanted to be able to execute, and I'm about to do it. So if I cut and paste this and hit enter, if you pay attention to the video feed, there's my finger pointing it, if I can get it about right, you will see, I've got it off camera at the moment, let me get, can I get that to do something useful? I will hold my finger down so you see the green light go on. That's the whole purpose of this talk, seeing a green light go on. So I will cut and paste this code. And the green light is not on. There's an error. What have I done wrong? Thank you very much. So let's see if I can scroll up and spot where it went wrong. GPO set direction, didn't get right. Okay, let's see if it'll recover with just sending it new. And if it doesn't, I'll just restart. Oh, you think it was the one before?
Well, you had the at the top now.
Ah.
You cut. No, one more.
Oh.
Put that. You cut, leaving the 2 zeros out of the. Yeah, see that?
Right.
It
was the constants that were wrong.
You left the last 2 zeros and the.
Semicolon. So it will probably be all of these that it will want again. Let's try that, see whether I'm lucky. No errors. Let's see whether it works. Just to prove it's a real demo, really live. Still wrong. I am just going to quit while I'm ahead and restart. So always the best thing. So I will reflash the Pico so it's in a known state. Okay, and then I'll just confirm that, yep. So let's start again. Yell at me if I get it wrong. Okay, I think it's one time. Yep. Have, of course, rehearsed this a number of times. Yeah, demos are demos. Let's get this right this time. So maybe like this. Okay, and then let's do 2 functions at once. Yep. And then let's pass one in. Oops. What's fun is that VS Code does a pretty good job of managing syntax for a language it's never seen before. Right, and then finally, we put in the code from the slide earlier, and this time the light comes on. Right, that's the whole reason for the talk. No, it's not. The reason for the talk is to get you to try this. Yes. So let's get the presentation back and recap where we've been. Okay, so, and as you can see, I am prepared. There is a little picture of a green light on there, so you can imagine I didn't do that 10 minutes.
Saw it in real life. It's awesome.
Absolutely. Saw it for real with hugely over-engineered presentation with multiple cameras and all that kind of stuff. So, recap where we've been. Customizing locks, go Google it. It's a great language, and you can have your own program on a Pico, and it's programming language, and it's fun. I mean, writing that Conway's Life thing, which you've seen a picture of, it was fun. It was my programming language that was running. I happily will take questions about what I added to get there. Porting C on the Pico, dead easy. The SDK is very high quality. The standard library is very high quality. Everything just worked. Locks has very few dependencies. That's an important point. Add 3 features to get what you want language-wise. So hex constants that you can read with sanity. Bitwise operations, that's very important. Peek and poke. And then you can turn on the LED. Before I stop for questions, I have an advert. So fair disclosure, and I did talk to Richard about this before. If you're in Surrey or the area, you may have heard of Barcamp London, which happens every now and again. One of the people who attends that regularly, he's an old colleague of mine from when I worked on Ubuntu. He is running Barcamp Surrey. This is an advert for Barcamp Surrey. I will be there. It's pretty much all there is to say because it gets made up on the day what happens on Barcamp. So, you know, if you're in the area, if Godalming is a place you can get to in August, feel free to come along, check out the link.
What actually happens there?
Tech conference that gets organized on the day. So it self-organizes, there's no pre-planned talks. I'll be there. I imagine I might talk about some of this stuff. It's kind of exciting for me, but maybe everyone will say, you know, don't talk about that.
So is it just talks or is it
practical? Can be anything. The website goes into a bit more detail with some ideas. Quite likely it's going to be a bunch of people with some laptops and they'll want to talk about some things. And maybe people will bring along some stuff that they've been working.
This isn't full of middle-aged men, is it?
I hope not. I do hope not. But there are biases in many things, right? So, yeah, check out the link on the website. I'm just going along, but well, I'm going to help organize, but it's not me organizing.
Very cool.
And so with that, any questions?
So what are your next steps on? Like,
So
it seems like a lot of work to do that.
agreed.
So is this, I assume this is something you've always wanted to do, like sort of build your own language and,
Turned out it was, right? I didn't know it was something I always wanted to do, but when the idea came along, yes, something I've always wanted to do. The next steps for me are things that I've done that aren't in this presentation. So to get to the stage you see on the picture there, I needed to add proper integer support because I didn't want to get into, so the language now has 2 number types. I need to add arrays because that's a 64 element array, and managing those one by one is really tedious. It's pretty much what I added. The other thing I want to do in the future is add support for interrupts. The thing I observe in a lot of languages is there's no language support for those. You reach a place in the documentation where it says, implement a function, assemble it attach it to an interrupt, and be careful what you do inside. It says, don't call this, don't use memory. By the way, if you do these things, it'll sort of work, but then eventually it won't. I want to support that in the language. So there's a language called Lua that has coroutines that are cooperative way of multitasking. And I've been reading, that's mentioned in the book, followed up, and it turns out I'll be able to declare a function with the notion that it will always be running an interrupt. And then the language will tell you whether you're doing it right or not. Right. So you'll get correctness out of the box. And with those 2 things, then then the world is, and I'll be saying, then I'll come and do a talk saying, come use my cool language. Because with those 2 things, I think it's quite interesting. With just arrays enough to turn on LEDs, you're welcome to go look at it, but I think it needs a little more work before it's ready for someone to use it.
very interesting. I just not something that ever crossed my mind to do.
Absolutely. Everything you've seen runs on the Pico. And it doesn't even stretch the Pico. It actually gets converted to it gets tokenized, and then it gets converted to a bytecode representation, which is then executed by a C virtual machine, which you write. So I've got all of that C running on the Pico. And eventually you can kind of rewrite that in your own language. That's a language goal, but I don't do that. So at its core, it's C, and it's the C compiler managing assembler for me, right? I don't have to do that. I'll add it eventually, but I don't need it on day one.
Is there a whole community of people like doing this sort of thing out there in the net?
There is. Locks is very popular. The book is very popular, and you go to the wiki page with Locks implementations, and it's very, very long. I haven't seen many doing it on microcontrollers.
Right.
I think a lot of the interest in microcontrollers seems to be taking, your favorite language, Python, Go, Lua, all of them, Lisp, and porting it to a microcontroller, and then writing a doc that says, by the way, these things don't work.
Okay.
It's that doc that I want to eliminate, or to just not have that.
Right.
When you choose this language versus I don't know port, like a completely other way.
Because I found there's a conference that I've been following online, and the author spoke there, and he said, I've written this book about how to write a language. And I thought, I'm going to read that book.
All right.
Yep, absolutely.
Do you remember the author's name?
The author's name is, I'm going to just put it, it's the easiest thing to do. Website. Robert Nystrom, who is relatively well known for these things. He's also done some game programming and other things. Yeah, these days he works on Dart at Google, apparently. The book is fully available there for free. You can also buy it on Amazon if you want a thick piece of paper.
That's very cool and very very unexpected. Never expected anyone at Raspberry Pi talking about building companies. Quite different from what normally.
I want to get to the stage where I can write. So I've got this one thing written, and I've also been learning KiCad and board design and things like that at the moment. I want to write some programs that respond to interrupts, and then I kind of claim that I'm theoretically done, and I'll come and talk to you about why you should come and use my language. I'm a long way from done at that point, but at least I'll be able to talk about it.
If you are using C control, you can create the same editor actually, line 10.
So, yeah. It's a lot of fun to be had. Yeah.
Very cool. Any questions from online? No. Okay, thanks very much, Sean. That was really good.